So today we're in section 6.4, covering similar and congruent figures. All right, first I want to start with just some terms and definitions. You don't have to write this down because we've got it right there in the book. But these are just some terms that will help us understand the lesson a little bit better. All right, so pay attention to the screen. Two figures are similar if they have the same what? Shape, but not necessarily the same size. So they could be larger or smaller, but they are the same shape. Look at the two comparisons underneath. We see that the green triangles, yes, are similar. They are shown to be similar with the sign also. You see the squiggly sign that shows that two figures are similar. The figures on the right are two completely different triangles. They're not similar figures, so the corresponding angles and sides and their congruent measures would not apply. So let's look now at the second part to this definition. Corresponding parts of figures have the same relative position and have the same value. Okay, so that you'll see later in the lesson how that can help us find unknown angle and side measurements because we can compare back and forth. Okay, so good so far. Similar figures have corresponding angles and sides. So let's look at that a little more closely. Okay, it says given triangle LMN is similar. How do I know it's similar? Because it's got the similar sign right there to triangle PQR. Name the corresponding angles and the corresponding sides. Well, you see right away, are these figures drawn in the same directions? Are they drawn in the same direction? No, they're not. So that can immediately kind of throw us for a loop because visually we want to match up the angles and sides. But a lot of times that can be misleading and deceiving, okay? So the way that I would encourage you to match corresponding angles and sides is by looking at the order in which they're written in the example. For example, what is the very first angle that's mentioned in this triangle? Angle L, okay? So we use an angle sign. Yes, it looks like an L, but it's not. Angle L. Our congruent sign is measured by is written with an equal sign and a squiggly on top. Angle L is congruent to the first angle mentioned in the second triangle. Angle what? P. Okay, you see how I use that order? All right, so I'm essentially not even, goodness, I can't write a P. Not even looking at the figures. Okay, what about the second angle? Angle M. Angle M would be congruent to which angle? Angle Q. All right, and then the last one, angle N, is congruent to angle R. So there we go. There we have it. We have our three pairs of corresponding angles. You've got number 2, number 3, ask for corresponding angles and sides, number 7, number 8. Okay, so this example will help you on those questions. Now that we have corresponding angles, let's look at corresponding sides. For corresponding sides, I use a line above the angles that are being connected. So I start with the first two angles in this triangle. Angle L and angle M connect to form a side. Side LM is congruent to side what? PQ. The first two angles in the second triangle to side PQ. So now I'm going to go side MN. And what two angles or what side would that be congruent to in the second triangle? What do you think? QR. All right, so then our last one would be side LN is congruent to side PR. Right? Yep, PR. And there we go. 3 pairs of congruent angles or corresponding angles and 3 pairs of corresponding sides. Any questions? All right, so now let's look at corresponding angles and sides with the quadrilateral. So now I'm going to have 4 pairs. Why am I going to have 4 pairs and not 3? Because there's 4 angles and 4 sides. So now I have 4 pair. And again, okay, the book's going to make it difficult. The figures don't exactly mirror each other, right? One's flipped. Okay, so sometimes looks can be deceiving and you can get confused. That's why I encourage you to go by the order in which they're listed in the similarity in the example. A, B, C, D, it's similar to W, X, Y, Z. So if I'm looking for corresponding angle to angle A, angle A is corresponding to what angle? Angle W. You fill in the other 3. Other 3 angles. All right, hold on. Angle B and angle X. All right, let me switch over to the slide where I actually already wrote this. All right, angle B and X, angle C and angle Y, right? Angle D and Z. Who got those right? Good. Okay, what about the sides? Have you done the sides yet? Yes. Okay, so side AB is corresponding to WX. All right, take a minute to fill in the other 3. All right, so second pair. CD, I'm sorry, BC and XY and CD and YZ. And then AD and WZ. Okay, so corresponding angles, corresponding sides. All right, now in example 2, now I'm asked to find the ratio of corresponding side lengths. Here's what's important. The figures have to be similar in order for this to work. So since I know the figures are similar, I can find one of the corresponding sides and form a ratio. It doesn't matter what pair of corresponding sides I pick. Doesn't matter. You can pick any pair of corresponding sides. Just make sure it's corresponding. For me, I like to keep it simple and just choose the first 2. So if I choose side AB, remember I'm forming a ratio. So what is the corresponding side to side AB? Which side is corresponding to AB? JK. Do you see that? Side AB corresponds to side JK. So what is the value for side AB? 8. What is the value for side JK? 12. Now reduce it, and that's your ratio. Number 4, number 9, 10, 11, and 12. This is what you're doing, giving me a ratio for the corresponding side lengths. Guys, if you pick any one of the other 3 corresponding pairs, it will be 2/3. Let's pick another one just to kind of prove the point. You only have to have one, but let's just do another one. What if we did side BC? What is the corresponding side to BC? KL. What is it? KL. So what's the value for BC and KL? Go ahead and write it down. Value for BC is 2. Value for KL is 3. So point proven, no matter which ratio, which pair you pick, as long as you reduce it, it's going to be 2/3. You only have to do one, though, for the questions on your homework. Okay? All right, so that's example 2. Now, in example 3, I'm checking for similarity. Here, okay, as we saw in example 1, sometimes looks can be more or less deceiving. So I would go more with what the example is telling you than what you're seeing in the picture. All right. Now we need to form a proportion here in order to be able to see if these figures are actually similar. Let's read the example together on the bottom of page 289. Open your books to the bottom of page 289 under example 3. A soccer field is a rectangle that is 70 yards long and 40 yards wide. The penalty area of a soccer field of the soccer field is a rectangle also that's 35 yards long and 14 yards wide. Is the penalty area similar to the field? Okay, so again, if you remember back to setting up proportions, I know it's been a while, but remember we have to be comparing the same thing on both sides of the proportion. So if it's length of the field over length of the penalty area equals length of or width of the field over width of the penalty, or there's a couple different ways to do it, but you have to make sure you're comparing same thing. What I chose to do is length of the field over length of penalty equals width of field over width of penalty. Do you see? Hold on one sec. Okay, sorry, I just had a little technical difficulty, but okay, guys, pay attention up here. Okay, so I'm just going to abbreviate because I don't want to write all that out again, but length of the field over length of the penalty equals width of the field over width of the penalty. Okay, so I'm just abbreviating. So now I'm comparing field over penalty on both sides, so I'm good. Now let's plug in the values. Again, use the word problem versus the figure because I feel like the figure's a little misleading. It looks like 14 is the length, but it's not. So length of the field is 70. What's the length of the penalty? 35. Width of the field is what? 40. Width of the penalty is what? 14. So now do cross products and see if your numbers are equal. Okay, so 70 times 14 is what? 980? All right, 35 times 40? 1400. Not equal. So I say not similar. And that's my answer. Okay, the reason I have to say not similar is because that's what the question was asking me. Are they similar? Right? And I say no, they're not similar. All right, now this will help you on, you can say no, yes, that's fine. This will help you on number 20. You're comparing computer screens. This is going to help you on number 20. All right, one more example. Congruent figures. So we've learned about similar figures. What does it mean for figures to be congruent? Well, they have the same shape and the same size. And we see this notated by these little angle markings. Okay, so angle L would be congruent to which angle? Which other angle has 3 markings? R. Angle R. Do you see how they compare? There's a little typo right here. Don't worry about it. Okay, so I use the markings to see which sides and angles are congruent. All right, that's what the markings are for. So here's how this applies. If these figures are truly congruent, and actually there's an error here in these, so I need to switch over to my screen real quick for a different example. This one will work. So look on the top line. It says ABCD, figure ABCD, is congruent to WXYZ. Not similar, congruent to WXYZ. So I can use corresponding angles and sides to find the unknown measure. They'll be the same measure. Okay? So I need to know the length of side WZ. Well, what is the corresponding side to WZ? A and D, very good, because WZ is on the outside here, first and last, so A and D would be the corresponding side, and what is the length of AD?
12.
So WZ is 12. What about angle W? What's the corresponding angle to angle W?
A.
Angle A, thank you. Right? Angle W is the first one listed. Angle A is the first one listed. So that is my corresponding angle. And what's the value for angle W? Or I'm sorry, angle A. Angle A is what? 105. Therefore, angle W is 105. You tracking with me? So now you solve one. Measure of angle Y. Find it. Okay, so angle Y, I'm going to say it again, is the third angle in the sequence. Angle C is the third angle in the sequence. Angle C is 80 degrees. Therefore, angle Y is 80 degrees also. Now I want you to find the value for side CD. Find its corresponding side, whatever value that one is, that's the value that will be for CD as well. Which side is corresponding to CD?
YZ.
Very good, because it's the last two in the sequence. So on the other quadrilateral, it's the last two also. So what is the measure for YZ?
16 meters.
So guess what? CD is 16 meters. All right, did you get it right? Okay, that's everything you need to know. This will help you on 13, 14, and 15 on your homework, okay? That's all you need to know for 6.4.